Hi students, in this video we are going to solve problems related to special types of integrals. The question is evaluate integration of square root of 1 minus x divided by 1 plus x. Whenever you have in this fraction form and 1 minus x divided by 1 plus x, what we do is we will take the conjugate of the denominator. Using that we will multiply numerator and denominator and the problem can be solved then. So if you observe it, the conjugate of 1 plus x is 1 minus x. So we are taking square root of 1 minus x to multiply numerator and denominator. This when we multiply this we will get 1 minus x, and in the denominator we will get root over of 1 minus 1 square minus x square. That is, here if you look at this, it is 1 plus a plus b into a minus b form. So you square root of a square minus b square is there. After that we will split this integration into two different integration. Using this 1 divided by square root of 1 minus x square dx, we have one integration, minus x into dx divided by square root of 1 minus x square. We know that integration of dx divided by square root of 1 minus x square is sine inverse of x. But here we don't have direct formula. To solve this integration, what we need to do is we will use substitution technique here. If you take the denominator, that is 1 minus x square, as you know this is the first function. It is a composition function. 1 minus x square is the first function. The output is given to the square root function and then it is multiplied by with x. Hence we take this 1 minus x square as t, means when we do derivative we will get minus 2x, because derivative of 1 is 0, derivative of minus x square is minus 2x. So here we have 2, but we need minus 2x. If we do derivative here, we are getting minus 2x here. Here we have only x, but we need minus 2x. In order to get minus 2x, what we do is numerator and denominator is multiplied by minus 2x, and then this problem can be solved easily. So what we do is, as I said earlier, this integration formula is sine inverse of x. This one for minus, as it is, we are multiplying numerator by minus 2 and denominator by minus 2. So if we take 1 minus x square as t, and then when we do derivative on both sides with respect to x, derivative of constant is 0, derivative of minus x square is minus 2x, derivative of t is dt by dx, dx has been transferred this side. So we got the denominator here. So in place of denominator we can, in place of minus 2x dx we can substitute dt divided by, in this place square root of 1 minus x square, we can substitute this t, minus half into minus becomes plus half, and then we got this. So this 1 by 2 into integration of this, in the denominator we have square root of t, that can be transferred to the numerator and it can be written as t to the power of minus half, and then we can use integration formula, that is t power minus half plus 1 divided by minus half plus 1. So we get t to the power of half divided by half. When we substitute this in place of t, if we substitute 1 minus x square, and then if we transfer this 2 to the numerator, this will get cancelled, 2 will get cancelled, we will get sine inverse of x plus root over of 1 minus x square plus c. I hope you understand this problem. Now we move on to next concept. The next concept is integration of the form integral dx divided by square root of ax square plus bx plus c. In the previous special types of problem, we had the same type of problem without square root. What we do is we applied completing the square method. After that we did the integration. Here also we are going to do the same step. We will see an example. With that example you will know how to solve it. Actually you solved many problems in this type, so it will be easy for you to understand. Evaluate integration of dx divided by square root of x square minus 3x plus 2. Here we have quadratic expression with middle term, but in all the formulas, special types of formula, we will have quadratic expression without middle term. Hence middle term should be removed. Hence we will use completing the square method. So you know that from the first we must make sure that coefficient of x square is 1. Here already the coefficient of x square is 1, hence there is no problem. We will take x out of this, and then whatever sign is here, that will be written. The coefficient of x will be divided by 2. Here coefficient of x is 3 and it is divided by 2 whole square. This plus 2 as it is, and then minus whatever value here. You should not consider this sign, you just consider this 3 by 2, that should be squared. So now we have to do the simplification. X minus 3 by 2 whole square, this 3 by 2 square is 9 by 4, and we do the simplification means we get this 1 by 4. So we get square root of 1 minus 3 by 2 whole square minus, this constant should be written in the form of square, hence it can be written as 1 by 2 whole square. Now it is in the form of integration of dx divided by square root of x square minus a square. The formula is log mod x plus question as it is. In place of x we have x minus 3 by 2, hence in place of x we are substituting x minus 3 by 2 and then question as it is, and then we need to do the simplification here. When we do the simplification we are getting this answer. I hope you understand this problem. Whenever we have a quadratic expression with middle term in the denominator, means using the completing the square method concept, we will remove the middle term and then we will try to apply the special types of integral formula, suitable formula, then we will get the answer. I hope you understand this problem. Now we move on to next question. Evaluate integration of cos x dx whole divided by square root of sin square x minus 2 sin x minus 3. If you observe the denominator, it is in the quadratic expression in sin x. What we can do is sin x can be taken as t, so that when we do derivative on both sides we get cos x dx is equal to dt. Hence this problem is the combination of substitution technique and 9 special integral type. So as I said, sin x will be considered as t, and then when we do derivative on both sides we get sin x derivative is cos x, derivative of t is dt by dx, dx will be transferred this side. So integration of dt divided by square root of, in place of sin x we are substituting t, so t square minus 2t minus 3. Here if you observe that it is in the quadratic form with middle term. Middle term can be removed using completing the square method. First we should make sure that coefficient of t square is 1. Here already coefficient of t square is 1, so there is no problem. So we need not take any number as common to make the coefficient of x square as 1. Now what we can do is, out of this t square we will take t, whatever symbol is here it should be written. Here we have minus sign, hence minus sign. Coefficient of t should be divided by 2 and it should be written inside the bracket and it should be squared, and then this minus 3 as it is, and then we put minus sign whatever value we have here. Don't consider this plus or minus sign, just consider this value that has to be squared. So we get t minus 2 will get cancelled, we get minus 1 square, and then minus of plus 1 square is plus 1, and then when it is multiplied by minus we get minus 1. Already we have minus 3, so minus 4, it can be written as minus of 2 square. So it is in the form of integration of dt divided by square root of x square minus a square. The formula is log mod x plus question as it is. In place of x we will substitute t minus 1, and then we do the substitution, because here we got the answer in terms of t, but we need the answer in terms of x. Hence in place of t we will substitute sin x, and then we do the simplification. We get the final answer. I hope you understand this problem. Now we move on to next question. The next question is, evaluate integration of e power x dx divided by square root of 5 minus 4 e power x minus e power 2x. Again if you observe this, in the denominator we have quadratic with middle term in e power x. Hence it is a combination of substitution technique and 9 special integral. Here as you know very well, e power x will be taken as t. So when we do derivative on both sides, we get e power x dx is equal to dt. Hence in place of e power x dx we can substitute dt, and in place of e power x we can substitute t. So we get this expression. So what we do is, here coefficient of x square is -1. We know that it is a quadratic expression with middle term, but in order to use special integral formula, we should remove this middle term. Hence we should make the coefficient of t square as 1, but here coefficient of t square is -1. Hence inside the square root we are taking -1 as common. This -1 should not be brought outside the square root, because it is mathematically wrong. Hence inside the square root we are taking -1 as common. So we got t square plus 4t minus 5, and then we will use the completing square method. Out of this t square we will take only t, and then whatever symbol is here, plus or minus, it should be same, should be written here. Here we have plus, hence we put the plus as it is. Coefficient of t should be divided by 2. Here we have 4 is divided by 2 means 2, and this sign should be put inside the inside the bracket, and it has to be squared, and then this -5 as it is, and then we have to put this minus sign. Whatever value here, we don't consider the symbol, whatever value is here, that should be squared. So 2 squared. So when we do the simplification, we get this expression. Now we got the quadratic expression without middle term. Now again we can multiply this minus sign inside the bracket, so that the question will be changed. Now initially -1 into x square minus a square formula. When we multiply this minus sign inside, it becomes a square minus x square formula, that is integration of dt divided by square root of a square minus x square. The formula is sin inverse of x by t. So sin inverse of, in place of x we put t plus 2 divided by, in place of a we are putting 3, so plus c, in place of t we are substituting e power x. With this we are completing the second set of 3 special type integrals. I hope you understand this, because all the concepts you used in here were already learnt in the previous concept itself. Thank you students. Thanks for your cooperation.